Hello, I'm Ole and I'm a PhD student and turbulence researcher at the Alfred Wegener Institute in Bremerhaven. Personally, I find turbulence a super fascinating topic, also because it can be found everywhere around us. For example, in cloud movement, in ocean currents, but also in something like your cup of tea in the morning. If you find your tea too hot, you may want to cool it down by adding cold milk. Pouring in the milk creates turbulent whirls, which mix the two fluids. In the case that you're impatient, you may take a spoon and start stirring. The mixing is now accelerated until the tea and the milk are no longer distinguishable. They are fully and irreversibly mixed. This observation of two fluids with different temperatures mixing can also be found in the ocean at much larger scales. In my PhD thesis, I researched processes that are actually quite similar to the mixing in a cup of tea. In this comparison, the cup itself corresponds to an underwater slope, close to the Antarctic continent, the hot tea to the Antarctic Ocean. The analogon to the cold milk is very dense water, flowing along the sloped seafloor into the deep sea. This water is originally from the surface, where the freezing Antarctic air cooled it down until it is denser than the water below it and sinks down. This can be visualized with a wine bottle filled with tap water and dyed salt water. The friction with the seafloor and the surrounding water lead, just like in the cup of tea, to turbulence and mixing of the two fluids. But back to our sketch. The last remaining role is the one of the spoon that accelerates the mixing. This role is filled by so-called internal waves. Internal waves are similar to the usual water waves we all know, but different to these surface waves, which are on the interface between water and the air. Internal waves are instead underwater, on the interface between two different water layers, or in this kitchen experiment, between oil and water. Like the spoon stirring the tea, they increase the mixing between the two water masses of different temperatures. In my PhD, I researched this interaction between the current along the seafloor and the internal waves to come up with laws that describe the resulting mixing. And this is how you can find some oceanography in a cup of tea. More about my research project and other interesting topics can be found on the TRR 181 website, Energy Transfers in Atmosphere and Ocean.